Hello and welcome back to another episode of Math with Son. Today we got a very important one. We got parallel lines and their transversals. All right, so the first thing we always like to do is just identify what type of transversal angle relationship we have. All right, so there's corresponding angles and alternate interior, alternate exterior, and consecutive interior, which I like to call same side interior, which means the exact same thing. Okay, so we're going to start with the interior ones. All right, so if it's an interior angle, it's either going to be alternate interior or same side, which is the same thing as consecutive back-to-back interior. All right, so these two on number 4, notice how they're on the same side of this transversal. That would mean that these are consecutive interior angles or same side interior because they're on the same side of that transversal. Whereas on this one, they're on the inside of this sandwich. See how like here we got a sandwich, the parallel line sandwich, the top and bottom, these two. But see how they're on the opposite side. So this would be alternate interior angles. All right. Now, let's focus on the exterior ones. There's a singular exterior, alternate exterior, and that happens when they're on opposite sides, but they're outside of the parallel sandwich. Here's the parallel lines. They're on the outside. This is alternate exterior here. Okay, so we've done alternate exterior. We've done the interior ones. The only one left is corresponding, and corresponding is different. It has one on the inside and one on the outside. Okay, and I like to think of the corresponding as like they can just slide down and replace it or slide up. So see how like this Y could slide down? That means that they are corresponding angles because they could slide down one on top of the other. All right. Now let's also tackle while we're here, which of these are equal? And the answer to that is almost all of them. Corresponding angles are congruent. Alternate exterior are congruent. Alternate interior are congruent. The only one that is not is consecutive interior, and those add to equal 180 degrees, out of the things named, at least. Okay? There are many more that are not named that are equal or congruent or add to 180. Okay? So I'm going to use number 6 as an example. Everything that I circle, all of those angles are equal to each other. All the circles are equal to each other. Now, everything I put an X in, all of these angles are also equal. So all the circles are equal and all the X's are equal. However, a circle and an X put together would equal 180. So these two would add to 180 because they're a line. These two, this circle and this X, would add to 180 because they are some sort of parallel transversal combination that adds to 180. So everything that is a circle is equal to each other, and everything that is an X is equal to each other, but things that are not alike add to 180. All right, got a few more naming things. Let's see what these two are. We got X on one side of a transversal and Y seemingly on the other, and if we look here and we look there, we have the parallel sandwich. So it's on the inside of the sandwich. It is alternate interior. What about over here? We got to identify the parallel lines. Here are the two parallel lines. And it looks like Y and X are on the outside of at least those parallel lines, so you don't pay attention to this one that I just scribbled out. So they're on the outside, and they're on opposite sides, so this would be alternate exterior angles. All right, let's move right along. Let's find the measure of each indicated angle. So going back to are they equal or are they not? Now, a big trick that you could do is visually look. This doesn't always work, but visually look and see for the obtuse angle. See how this angle is obtuse? Is the question mark also an obtuse angle? Yeah, because an acute angle is smaller than 90, so this is also going to equal 110. But you could do your circle idea. Circle here, vertical angle, circle. Circle here, vertical angle, circle. So all the circles are equal, which is why I put 110 for the question mark. Okay? Not only that, but they're alternate exterior. Alternate exterior equal. What about these two, 84 and question mark? Would they both be acute? They visually look it, and I do agree. They are also alternate exterior, which is equal. You can do your full circle or dot technique. I use dots sometimes, and they would feel like vertical, 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 vertical all around. Now over here, we got 100. I'm going to put a dot there. I'm going to put a dot here. across from it vertical, and then I'm going to go in the same bottom left, top right of that x. Now notice the question mark did not get a dot. If it does not get a dot, that means that 100 and the question mark do not equal each other, but they add to 180, which means that the question mark has to equal 80 degrees because 180 makes 180 degrees. Okay? Dot, 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 and dot. Uh-oh, we had a dot covered up quite literally the question mark, so it is 111. Dot for here, bottom left, top right. Bottom left, top right. The question mark is going to be 125. It's also alternate interior. This particular sheet loves alternate interior. 16 works best when you look at the is that an acute angle and is the question mark an acute angle. You can almost tell that these feel like vertical angles with a gap in between, and that is because they are still equal to each other. 47, all four corners, top right, bottom left are equal. My favorite corresponding angle, this angle looks like it could visually slide down there, which means that it is 53 as well. And not only that, but if you use the dot technique, dot, 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 bottom left, top right, 53 degrees again. And this one is going to be 113. Let's see if we can prove it. We got top left, bottom right. I flipped up the order, top left, bottom right. Same two quadrants, all four of these dots are equal, so that's 113. Now, inevitably, your geometry teacher is going to give you something with an equation where you gotta know to equal each other or add to 180. So in this case, let's just do number 20. Do they equal each other or do they add to 180? You got a dot here, you got a dot there, you got a dot here, you got a dot there. These are the acute angles and they would equal each other. 75 would equal 11x minus 2. Add the 2 over, 77 would equal 11x, and x would equal 7. Okay, no big deal there. Let's find one that might not be equal to each other. Actually, all of these are equal to each other, potentially, so let's just try a different one that looks a little different. Let's do this one, which is alternate exterior, which for some reason geometry textbooks don't care about. See how they're on the outside, but they're on opposite sides, so it's technically alternate exterior, but they never came up with a name for that. The dots are here, 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 here. Top left, bottom right, top left, bottom right. So that means they're equal to each other. -1 plus 14x would equal 12x plus 17. The geometry part is the easier part, potentially. We are going to add 1 over to this side. If we add 1, the -1 cancels. Add 1, we get 14x by itself equals 12x plus 18. Subtract the 12 from 14x, we get 2x is equal to 18. When we divide, you get x equals 9. All right? In this case, it wants you to find the angle indicated in bold. That is hard to see the bold. All right? I like this one. This is the bold one. And you have to ask yourself, do these add to equal each other? Well, they do equal each other. Because look, x plus 96 equals x plus 96. But if you do that, if you set x plus 96 equal to x plus 96, you're going to find out that this is not going to work out very well. All right? This is because x's cancel. X's go away. Okay, so that won't work. And that is because if we do the dot, which in this case I'm going to do as a circle technique, top left, bottom right, those shouldn't necessarily equal each other. More importantly, they need to add to equal 180. So x plus 96 plus x plus 96 would equal 180. All right? And now we can combine like terms. We got x and we got x, we got 2x. We got 96, we got 96. That's going to add to make 192 will equal 180. Subtract the 192. When we subtract 192 from 180, you end up with a -12, which means for the first time in a while, we get negative values for x. And it also wants you to find not the value for x, but it wants you to find the value of the bolded angle. If we plug in x, you're going to get -6 plus 96, which is 90. Well, that kind of tracks then, because both of these would be 90, and 90 and 90 add to 180. Okay? One more real quick one. Let's do number 27. It's my favorite. It's corresponding, so you have to ask yourself, do those two angles equal each other? And they do. All right, 6x would equal the 5x plus 10. Remember, we're not looking for x, we're looking for the value of the angle. But when we subtract 5x, we get 1x is equal to 10, which means x is equal to 10. If you plug in 10, 6 times 10 makes 60. And 5 times 10 plus 10 also equals 60. So the angle that is bolded, which actually was that one, it was kind of hard to see, is also 60 degrees. Until next time, everybody, stay positive, and I will see y'all later, my friends. Bye.